We're going to review our permutations and combinations again, just to make sure we've got the basics. And welcome back to Maths Playground. So our first question is, 6 members of a fencing team are lining up for a parade. In how many ways can they be arranged if the team captain, Madison, must always be at the front of the line? Okay, so Madison is always at the front of the line. And then we have 5 other people lining up behind Madison. So, since Madison's place is fixed in the front, this would be 5 factorial since only the 5 other people can do it. And this question would be permutations, obviously, because it says arranged. So permutation means like permute means arrange or line up in order. Well, combination means like the order doesn't matter at all. Okay, second question. In how many distinct ways can the letters of the word Mexico can be arranged? So again, this is permutations because we have the word arranged. And that means we have to find, that means the order does matter. So, Mexico has 6 letters. So this would just simply be 6 factorial, which is 720. Easy, right? Next question. How many distinct arrangements are possible using the letters of the word mathematics? Okay, so this is again permutations because we have arrangements. So as you can see, we have 2 M's here and here, 2 A's here and here, and 2 T's here and here. So we can do this easily. If there were no repeats, then this would be simply 11 factorial. And then since the 2 M's, the 2 A's, and the 2 T's can be switching places without anyone, but we can't tell. So these can be arranged in 2 factorial ways each. So we're going to divide by 2 factorial times 2 factorial times 2 factorial, which is equal to 11 times 10 times 9 times 8 times 8 times 7, not 8, times 11 times 6 times 5 times 4 times 3 times 2 times 1. All of this divided by 8, since 2 factorial is 2, so we end up with 2 times 2 times 2, which is 8 in the denominator. So we can cross out the 8 up here and cross out the 8 down here. They cancel each other out. We're left with 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is equal to 4, 9, 8, 9, 6, 0, 0. If you multiply it, big number. Next question. In how many ways can the letters of the word leading be arranged so that the vowels E, A, and I always stay together? Okay, again, we have the word arranged, which means this must be permutations, right? Okay, so um, since E, A, and I will be a group, we have L, G, L, G, and G. Each of these are their own groups. There's no rule about them being together or anything. But E, A, and I are one group together. So, so since there are five groups, we would do 5 factorial, but that's not all. Since we have E, A, and I, and they can arrange between themselves by 3 factorial, um, we have to multiply by 3 factorial because for every 5 factorial ways, E, A, and I can arrange it by themselves in 3 factorial ways, which would be 120 times 3 factorial is 6. So we just end up with 720. Okay, next question. From a group of 7 men and 4 women, a committee of 5 is to be formed. How many ways can this be done if the committee must consist of exactly 3 men and 2 women? So finally, we have a combinations question because we don't have to order them. Okay, so we have 7 men to choose 3 men from. So for the first man, we have 7 choices. For each of the 7 choices, we have 6 choices times 5 divided by 3 factorial. Since don't forget this is combinations, so we're dividing by 3 factorial because the 3 men can arrange in between themselves in 3 factorial ways. So we have to divide by 3 factorial, and then we have to multiply by now woman. We have 4 women. We have to choose 2 women out of 4. So for the first woman, we have 4 choices. For the second woman, we have 3 choices divided by 2 factorial because the woman can arrange in between themselves in 2 factorial ways. And again, this is combination, so the order does not matter. So we end up with 35 times 6, which is 210. Okay, finally we ended up with a combinations question. Next question. In a standard deck of 52 cards, how many 5-card combinations are possible that contain exactly one ace? So this is obviously a combinations problem since it has the word combinations. So in a deck of cards, there are usually 4 aces. So if I did A1, A2, A3, and A4, let's say for the combination we got A1. So so now we can't get another one of these aces, so we have to throw these out, which leaves us with 48 cards for the um for the next card, and then 47 times 46 times 45. So Because every for every one of the 48 guards you can choose as a second guard, there's 47 options left for the third guard, and so on until 45, since we need only 5 guards. So we end up with, if you do multiply it, you should get 4, 6, 6, 9, 9, 2, 0. Looks like it's really hard to multiply. But here's the trick. We can choose one ace in 4 ways. So for each of the 4 aces, we we can multiply. We have 48 times 47 times 46 times 45 ways, right? So we end up with a huge number, 18,679,680. Wow. Okay, so now we have an now we have to move on to the next question. A customer is ordering a pizza and can select 3 different toppings from a list of 9. How many different pizzas can be made? So this is a combinations problem because it doesn't matter what order you put the toppings by. So so um so let's do this similarly to permutations. We would have 9 times 8 times 7, but since there's 3 factorial ways that you can order 3 factorial orders, which you can put the toppings on by. We're going to divide by 3 factorial since this is a combinations problem. So we have 9 times 8 times 7 divided by 3 times 2 times 1. So if we cancel out 9 and 3, we have a 3 here. Then 2, 8, 4. So we end up with 12 times 7, which is 84. Okay, so let's move on to our next question. If 12 people at a party each shake hands exactly once with everyone else in the room, how many total handshakes take place? Okay, so since you can't shake hands with yourself, the first person who shakes hands with everyone would have to do 11 handshakes. Then the next person who shakes hands with everyone has to do 10 handshakes since he or she has already handshake one person. And then so on, plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Okay, so 11 plus 1, that's 12. So how many groups of 12 can we find? 12 plus 12, 24. 24 plus 12, 36. 36 plus 12 would be 48. 48 plus 12 is 60. And then, so we end up with 66. Okay. Next question. In a show competition with 12 horses, the top 3 winning horses receive money. How many possible money winning orders, first, second, and third, are there? Okay, so for the first place, we have 12 choices to choose a horse. For the horse that gets second place, there's 11 other horses who can take second place. And then for each of those, we have 10 other horses who can get third place, which is 1,320. Still pretty easy. Okay, last question. A teacher needs to choose a committee of 5 students from a class of 25. In how many different ways can this committee be formed? Obviously, this is a combinations question because we don't have to order anything. So if we try this like permutations, but we're not going to make the answer like we would if this were permutations. So we have 25 students for we have 25 choices to choose a student, and then for every one of those 25 students, we have 24 other students who can be the second person in the committee, and then we have 23 times 22 times 21. And we have to divide all of this by 5 factorial because this is combination, and the students can arrange themselves in 5 factorial ways. So we have 25 times 24 times 23 times 22 times 21 divided by 120. So 24 and 120 can cancel each other out. We're left with 5 here. Blah, blah. We're left with 5 here. And if you multiply this, you should end up with 5, 3, 1, 3, 0. Okay, and that's our last question for today. See you later.